Welcome back to freehighschooleducation.com. Today we are going to do an exercise session for chapter 5.7 on page 194. This is the chapter of inequalities with absolute value. In the first session when we explained this, we showed how we solve this using the number line, and that's how these exercises should be solved. In the second session, we showed a quick way of solving these. The student should master the first way of solving these exercises by using the number line. And then when you have mastered that way, you can use the quick way, since you already understand how things work. Now, before we start solving any of the exercises, there are a few situations that we have to take care of. And whenever we meet any of these situations, then we will know the answer. For example, if we have something like this, or any other absolute, for example, absolute x minus 5 less than minus 3, if we reach at the end of the exercise to a stage like this, where we have a positive absolute, and it's less than a negative number, then that's an impossible situation, because whatever is inside the absolute cannot be a negative number, and so it cannot be less than a negative number. All of these are positive numbers when they come out from the absolute. So they are going to be more than the negative number. So for all these exercises, the answer is x equals not 7. Now the other situation is something like this. Absolute x more than minus 1, or any other absolute more than a negative number. And again, we have to pay attention here that we have a positive absolute more than the negative number. In this situation, this is a positive number on this side of the inequality, and this is a negative number. So this number is always going to be more than that amount. And so the answer for these situations is x equals all real numbers. So now we are going to solve some of the exercises on page 194. We start with the written exercises. Number 1, absolute x less than 4. Let's see it on the number line. Here we have our x is between minus 4 and 4. So we can write this inequality as such. And here, in fact, we have two inequalities. We have one which is x more than minus 4, and this we graph it this way. And we have one where x is less than 4, and we graph this way. And since this is a conjunction and, then we are looking for the common region, and that will be between minus 4 and 4. So the answer for this inequality is x between minus 4 and 4, and at 4 and minus 4 we have open circles because these are not included in the solution set. Now the second exercise is number 2, and here absolute x is more than or equal to 4. The values where x is more than 4 units away from 0 would be in this region or in this region. And we're talking of the absolute value. So here we have minus 5 comes out from the absolute as 5, and that's more than 4 units away from 0. So this is here, these two sets are the acceptable solutions for this inequality. And since 4 is included, so it will be here. And here, on these 2 points, we have solid circles. And this can be rewritten, as we have said previously, as a disjunction as such: x more than 4 or x less than minus 4. And these two are tied with the word or. And this is the graph for this inequality. Now, number 3, absolute x is more than 0. Here, any number more than 0 fits, and 0 is excluded, so we have an open circle on 0. And also, numbers in the negative region, when they come out from the absolute, come out positive, and they are going to be more than 0. And again, for the second set, 0 is excluded. So the answer for this inequality is this graph. Now we're going to do number 8. Absolute less than or equal to none. Here we are going to use the quick way of solving this. So we pretend that this is an equality, and we solve this absolute. In the first instance, we are going to have 3x plus 3 equals to 9. And in the second instance, we are going to have 3x plus 3 equals to minus 9. And in this case, we are going to have two values, and these are the roots. And since this is less than, we are going to have the answer between the roots. So let's see how this works. First, we divide everything by 3, and that will give us x plus 1 equals to 3, and x equals to 2. So this is our first root. Here we divide by 3 again, and that's x plus 1 equals to minus 3, and x equals to, we take this to the other side, and that will be minus 1, and x equals to minus 4. And we are going to plot this. We put our roots on the number line, and our solution, since this is less than, will be between these two. And since we have equal, these two values, minus 4 and 2, are included in the set. And again, you can try 0 here. You will have 3, which is less than 9. So 0 works. You can try minus 10 and plus 10 and see if you get a false value. Next we'll do number 10, absolute 7z minus 14. 7z minus 14 less than 7. Again, we can use the quick way. We 7z minus 14 absolute equals to 7. We equate this to 7, and in this case we are going to have two situations. Once it is equal to 7, and once it is equal to minus 7. We solve both situations. Divide first by 7. Z minus 2 equals to 1, and z equals to 3. Take 2 to the other side. Again, we divide by 7. We get z minus 2 equals to minus 1. Z equals to 2 minus 1, and z equals to 1. So here we have two roots, 3 and 1. And our positive absolute here is less than 7. So it is going to be between the roots, the answer, the value of z, and our roots are 1 and 3, and they are not included in the inequality. So we put open circle on 1 and 3. Again, we try values outside the acceptable region, and a value from this region. In this case, you can try number 2, which is the easiest. If you try 0, for example, you are going to get 0 minus 14, less than 7, and then you get 14 outside the absolute. It will be 14, less than 7. Is it less than 7? And you see, no, it is not. And that's a false statement, so this value is not acceptable. And then if you try 2, you'll find that it gives you a true statement. If you try plus 10, it will give you a false statement. Next, we'll do number 12, 6k minus 18 within the absolute is less than or equal to 12. Here again, we're going to use the fast way. We are going to equate our absolute to 12 and get the roots. So 6k minus 18 equals to 12. Here we have two situations, 6k minus 18 equals to 12, or 6k minus 18 equals to minus 12. We divide everything by 6, and we get k minus 3 is equal to 2, and k equals to 5. Divide everything by 6 here, you get k minus 3 is equal to minus 2, and k equals to 3 minus 2, and k is equal to 1. So our roots are 5 and 1. Now we look at our absolute. Our positive absolute is less than this number. So the answer is going to be between the roots. So k is going to lie between 1 and 5. So this is 0, 1, 5, k is between these values, and we darken 1 and 5 because they are included in the set. So this is the answer to this inequality. Let's do number 14. Absolute minus 3 plus 2y. More than or equal to 9. Again, we equate this to 9, and we get two situations, 2y minus 3 equals to 9, or 2y minus 3 equals to minus 9. We solve this, 2y equals to 9 plus 3, and that's 12, and y equals to 6. We solve this one, 2y equals to 3 minus 9, and 2y equals to minus 6, and y equals to minus 3. Divide everything by 2. So here we have two roots, minus 3 and 6. And since our absolute, and again we notice that this is a positive absolute, we have to reach this point at the end of the exercise before we can say that this is outside the roots. Our absolute should be positive, and then we look here, see more than or less than. If it is more than, then the answer is outside the roots. And some people memorize this as lower than the lower, greater than the greater. Minus 3 and 6. So it is lower than the lower, greater than the greater, or outside the roots. And here, 6 and minus 3 are included because we have the equal sign here. And so this will be the answer to this inequality. So with this, we come to the end of this session, and we hope to see you again.